This section is VRP operating system image management and represents a means of providing recovery solutions in the event of image loss. Effective network administration and management within an enterprise network relies on all devices maintaining backup files in the event of system failures or other events that may result in loss of important system files and data. Remote servers that use the file transfer protocol service are often used to ensure files are maintained for backup and retrieval purposes as and when needed. The means for establishing communication with such application services is introduced in this section. So upon completion of this section, it is generally expected that trainees will be able to explain the importance of maintaining up-to-date versions of VRP, establish a client relationship with an FTP server, and successfully upgrade a VRP system image. As new features are introduced and improvements made to the current VRP product, the device is generally expected to be upgraded with the new image. As we have mentioned, the version of VRP used commonly by AIG3 series devices is that of VRP version 5. As new versions of the VRP image are released, we see this version increment and the product number providing some clearer information regarding the level of changes that have been made. The V value product version represents the product code and is generally fixed. Where a major version release occurs, however, we will see the product version update and is referenced by the R value, while a new minor update of the current version will be referenced by the C value. The example we show here gives a true reference to an upgrade from VRP version 5.9 to version 5.120 and the respective product codes for each version upgrade. A file transfer involves the moving of a file from one storage location to another. The storage location from which the file is being retrieved is generally understood to be remote, meaning that files are transferred between storage locations belonging to different devices. The example we see here shows a typical architecture under which file transfers are performed. These involve the base device, which in this case is RTA, and the file transfer server that uses a protocol such as FTP, which we will introduce in more detail later in this course. RTA may employ the FTP server as a central storage location for retrieving new VRP images for image upgrading, or as a location for storing system logs and backing up configuration files in the event that, for whatever reason, a configuration file is inadvertently lost. File transfer may be performed using a number of means. However, the common methods that are employed include FTP and TFTP. FTP relies on the establishment of a TCP-based connection to establish and maintain communication, as well as ensure all files transferred between the source and destination are delivered without loss. The use of TFTP employs the UDP protocol, which is considered to allow the overhead to be minimized for file transfer in order to allow more data to be carried in each packet. Since there is no real support for acknowledgements to ensure the reliability, TFTP will in fact support messages within the application itself to manage the connection and send acknowledgements of data transfer rather than rely on TCP to perform this. We give an example here of how the upgrade process is performed in the case that the device supporting VRP acts as a client and wishes to connect to a server that supports file transfer. The first steps here involve establishing the system name for the device and the assigning of an IP address to the device to allow IP communication between the router and the server to be achieved. In this example, the router named RTA, that is acting as a client, and the FTP server are assigned as part of the same network. The address 10.1.1.1 with the mask of 255.255.255.0 is configured on RTA, as can be understood from the 24 prefix value. Prior to the transfer of files to the client from the FTP server, it is imperative to ensure that there is enough physical space available in the system storage of the client. Through using the directory command in the user view, we are able to identify within the storage location of the device that is considered to be the local current directory exactly how much space is available. If the free space is less than the space required in order to transfer the image, the delete command can be used to delete selected files within the client storage location. If there is enough free storage space within the client, a connection to the file server, which in this case is the FTP server, can be established. For FTP connections, the command FTP followed by the IP address of the FTP server is used to initiate the connection, which will prompt for authentication of the client to ensure that the user has permission to access the FTP server. In this instance, the user and password is HUAWEI, and the user has been authenticated. We can see that the prompt shows that the FTP service is now active and FTP-based commands can be used. The getVRP.cc allows the client to retrieve a copy of the file named VRPCC from the FTP server. In the case of a TFTP server, the connection establishment is somewhat more transparent, since it is carried out as part of the file transfer process of TFTP. We see in this instance that the TFTP process is initiated through the TFTP command and the destination of the server is specified, along with the file to be transferred. The result allows the file to again be reliably transferred through acknowledgements sent by TFTP rather than through TCP. The retrieval of an image file, as we have seen performed with both FTP and TFTP and represented by the .cc extension, should now be present within the storage of the client device, which in this case is RTA. In order for the new image to be used, however, it is necessary that the new image be specified as the image for next startup. The vrp.cc file that was retrieved from the FTP server is now shown as being set to be the image for use during the next startup, using the command startup system software followed by the image name and extension. Once this command has succeeded, the display startup command can be used to view the resulting changes. In particular, we should look at the next startup system software option, which now shows vrp.cc as the VRP image that is to be used following restart of RTA. When it has been confirmed that the correct VRP image has been configured for use during the next restart, the device should be restarted to allow the changes to take effect. We should take note that the system is currently in the user view in order to perform the reboot process, for which the command reboot is used. The device will not reboot, however, until any configuration changes have been saved or are to be discarded. The prompt mentions that all configuration will be saved to the configuration file as part of the reboot process, which in this case refers to the saved configuration file. If these configuration changes are not expected to be saved, the N option should be chosen. Otherwise, any configuration will be saved before reboot. If you are not sure what the configuration changes are, the compare configuration command can be used. Following this, the confirmation prompt to reboot the device will be given, which should be approved by the user to allow the new image to take effect. In summary then, we have a couple of questions. The first is, what should be configured on the client in order to establish a connection to an FTP server? Well, the client must be able to reach the FTP server over IP, and therefore have a valid path to the FTP server. This means an IP address must be configured on the interface via which the FTP server is reached. How can a user confirm that changes to the startup software have taken effect after a reboot of the device? By using the command display startup, we can confirm that the new image has been applied and is currently active, identified by the .cc extension. This image should also be seen as part of the device startup process, as we saw in the navigating the CLI section.